Here is a simple demo that lets you see what is the condition for stability when buoyancy is involved. Like, why is it that when I put this bottle that it turns on the side and it doesn't want to float in the vertical direction? Okay, so I have a cup, plastic cup. This might work a little better with the styrofoam cup, and I put 15 quarters in it. And you can keep adding quarters and the cup is still gonna sustain the weight. Like if I add another 5 to make it 20 and another 5, so now I have 25 quarters and the cup still floats. So I took 10 of the 25 quarters out, so I still have 15 quarters in there and 10 in my hand. And now what I'm gonna do is I'm gonna put a little top on top of the cup. I just cut a little bit of plastic from a packaging, and I'm gonna see how many quarters can I put on top before the cup capsizes. So 3, 4, that makes it 19, 20, 21, and there we go. So I was able to put 25 quarters in the cup and it was still floating, but when I put 6 quarters on the top, making it 21, the whole thing capsizes. Why is that? So when I put the lid and add the extra quarters on the top, I'm effectively changing the center of mass of the object that I'm trying to float here, right? The center of mass is moving higher. Okay, so what is the relationship between the center of mass and the floating stability? Well, there are two centers involved when it comes to buoyancy. So you have the center of mass of the object. So let's assume a perfectly symmetrical object where the center of mass is in the geometrical center of the object. And then you have the center of buoyancy. So the center of buoyancy is basically the center of mass of the displaced fluid. So if you can imagine a volume of the displaced fluid, and the center of mass of that fluid will be what we'll consider the center of buoyancy for the object. So if the center of mass of the object sits below, on a perfectly vertical line, below the center of buoyancy, the object would be stably floating. In fact, even if you introduce a little bit of a rotation here, there will be restoring forces that would come back to equilibrium. Okay, but if the center of buoyancy happens to be below the center of mass of the object, okay, effectively acting as a pivot for rotation, for torque. And if the center of mass, center of object, center of mass, center of buoyancy kind of axis gets tilted a little bit, the object would experience a torque around the center of buoyancy, where the force will be applied at the center of the mass. So this is an unstable situation. So that condition needs to be met for the center of buoyancy to be above the center of mass for an object to float stably. To understand the nature of the buoyancy force, you should think about the pressure difference with height. So for instance, if you're in water, the deeper you go in the water, the more weight is pressing down on you from all the water that's on top of you. So you're going to experience a higher pressure near the bottom of an object and lower pressure near the top of the object. So pressure in fluids is applied in all directions. So even at the top, the pressure is going to be pushing down on the object. On the bottom is going to be pushing up. So you're going to have a pressure gradient or a net force pushing up. And that is really the buoyancy force. Same thing in air. In air, the pressure changes with altitude, and the higher you go, the less air molecules are sitting on top of your head, so the lower the pressure.